Okay, let's take a look at how to graph compound inequalities. So when we're talking about compound inequalities, it involves more than one inequality. So let's look at this first example here. Graph x, the set of values of x, such that x is less than or equal to -2, or, which we could represent with that union symbol, x is greater than 3. Like that kind of squish there. Okay, so let's break this down. What does that mean? We're going to graph all the values of x that are less than or equal to -2. So I'm going to put some numbers on this number line. I have the 0 there, but I want to make sure -2 shows up on my number line, which it will with if I just go by ones here. And I can go, oh, yeah, that works. And I'm going to call this number line x because I'm graphing all the values of x on this number line. And then we're also going to write the solution in interval notation. So x is less than or equal to -2. So go to -2, and you're going to determine if -2 is included or not included. Remember, with interval notation, if it's included, we're going to use a square bracket, and if it's not included, we use round parentheses for interval notation. And so x is less than or equal to, so when you see that bar, you know it's included, -2. And the values that are less than or equal to -2 go to the left of -2. So I'm going to put a square bracket there and have it opening towards the left. And then I'm going to also graph values that are here or that are over here greater than 3. So here's where we have x equals 3. I don't want to include 3, so I'm going to put an open or round parenthesis opening to the right to indicate that we're talking about all of the values over here or over here. And they can't be in both places at once because they don't overlap. All right, so here's another example. We're going to graph x is all values of x such that, now this says, if I read it from left to right, it says -3 is less than or equal to x, which is less than or equal to 4. We're going to put on the number line all the values of x that are more than -3, greater than or equal to -3, and less than or equal to 4. And notice I said and. So here, I'm going to go back up here because we're not to example 1 down there yet. So let me draw a number line here and throw some numbers on that number line. And I want the numbers -3 and 4 to show up. So I'm going to put 0 about in the middle. And again, this is all the values of x that we're talking about. -1, -2, -3. You want to make the numbers convenient for what numbers are involved in the problem. And so if x is, right, what this is really saying is that x is stuck in between two numbers, and those numbers are -3 and +4. And it's all the values in between those two numbers. So if you want to break it up into two parts, you can. We're going to graph, like this first part is saying we want all the numbers that are great. And a lot of times we put this, we like to have the x on the other side just it's easier to read. If you want to switch where the variable is and where the number is, you can do that. You just need to make sure that you keep the inequality open to the same side. So notice it's open towards the x, so if you switch their locations, you got to also switch the direction of the sign. So this is saying x is greater than or equal to -3, which is including -3, so I'm going to make a square bracket at -3, and it's going to be the numbers more than that, greater than or equal to that. But then the second part says that x is also less than or equal to 4, and so if I go to 4, and I want all the numbers less than or equal to 4, and this was off a little bit, move that over. I'm talking about all these numbers in between. And the brackets themselves indicate that, but I'm just shading it in to kind of emphasize it. X is in between -3 and positive 4. So, you know, in the last example, I didn't do this, but I'll go back and do it. If we're going to write the solution in interval notation, we're going to rewrite this as an inequality notation, but the graph right up above is going to help us figure that out. We're going to have a bracket that corresponds with this, the lowest number that x can be that makes this true would be -3, and then we write a comma, and then we write the biggest number that x can be, which is over here at 4, and we make another square bracket. So that is the interval notation. Let's go back to this first example here, and if you guys want to try to write it on your own, that'd be good. The solution, we're going to write this whole thing in interval notation. So we're going from the lowest number, and remember these numbers are going forever in that negative direction. So the lowest x can be is -infinity, and then up to, where it stops right there, -2, and we're going to make a square bracket because it's included, because of that bar. And then we're going to do a union, because or means union. And then we're going to write down the next starting value, which is over here at 3, but not including 3, so we make it round. And then we're going up forever in the positive direction, so we go all the way up to positive infinity. And you make round parentheses around infinity or negative infinity always, because you can never actually include infinity or negative infinity. Okay, next let's look at solving compound inequalities. So here's an example. We have 2x minus 5, and it's greater than or equal to -3. It's less than or equal to +3. We're going to solve this for x. When you have, so this is called a compound inequality, so are the other ones, because we have more than, like, we have more than one inequality symbol involved. So we're going to try to, our goal, get x by itself in the middle, because x is in the middle, so that's what we're gonna try to get it there by itself. So you do this just like you would solve an equation, but when you have a compound inequality like this, you're gonna need to do the same thing to all three parts: the left, the middle, and the right. So to solve for x, we want to get rid of this plus or the -5, so I'm going to add 5. So I add 5 over here, I add 5 in the middle, and I add 5 on the right. So this is 2, keep the symbols the same. The -5 and +5 cancels out, so I just have 2x in the middle is less than or equal to 8. And then we have 2x in the middle, so we want to get rid of the 2, and it's 2 times x, so we're going to divide by 2. I'm going to move over here. So on the left I have a 1, in the middle, because that 2 over 2 was 1, I have 1x in the middle, or just x, and on the right side, 8 divided by 2 is 4. So I'm going to graph all of the values that are greater than or equal to 1, but also less than or equal to 4. So it's an and statement, because it's x is greater than or equal to 1, and it's less than or equal to 4. I'm going to get rid of this. It's in my way. So this part, x is greater than or equal to 1, is all of the numbers starting at 1, making it a square bracket because 1 is included. And we're going to move all the way up to any value up to 4, because x, this part is saying that x is less than or equal to 4, so it's any of those numbers in there. So you could pick any number in that region that I just put square brackets around. Like if you pick 3, does it fit this inequality? Is 3 greater than or equal to 1? Yes. Is it less than or equal to 4? Yes. You could put 2 in there. You could put 2.5. You could put any decimal, any number between 1 and 4, and it will be a solution to that. So then, again, if you want to write this in interval notation rather than this inequality notation, and I should be attentive to detail, I'm going to call this number line x. This inequality can be written in interval notation. The graph can help because we're going to use these same brackets. The left bracket is at 1, so I'm going to start at 1, and I go up to 4, and then it's also a square bracket at 4. There you go. Okay, this last example is also a compound inequality, but it's an or statement, And if it's an and statement, they're going to be shading in towards each other. And if it's an or statement, you're going to have two sections that are either over here or over there, and there's not going to be an overlap. So let's do this problem. So we'll start here. So basically you just have to do two problems and graph them each. So if I want to solve this for W. So I'm going to get rid of the plus 7 to start. So I'm going to subtract 7, subtract 7. I'm just going to focus on this side, and then I'll do the equation or inequality on the right in a minute. So I have 3W is less than or equal to -4 minus 7 more is -11. I divide by 3, and I'm going to get W is less than or equal to -11 thirds. Now you might look at that and go, oh my gosh, 11 thirds. That's fine. It's a number. We can turn it into a mixed number if you want to. 3 goes into that, and it's going to be a negative. It goes in 3 times with 2 left over, so -3 and 2/3. I'm looking for all the values. I'm going to write it over here, where W of W, so I'm going to call the number line W instead of X this time, that are less than or equal to -3 and 2/3. I don't normally turn mixed number or improper fractions into mixed numbers unless I need to graph it and figure out like where it would land on the number line, and then it might be a little bit easier. So we'll hold off on graphing this for a minute. Let's finish solving. Let's do the second piece over here. So I have 3W plus 7 is greater than or equal to 4. So I can subtract 7, 3W, the 7's cross, add to 0. And then this is +4 minus 3, which is -3. And then I'm going to divide by 3, and I get W is greater than or equal to -3 divided by 3 is -1. So, or W is greater than or equal to -1. So I'm going to graph that. I'll do the blue with the blue pen. W is less than or equal to -3 and 2/3. So -3 and 2/3 is approximately here. And it's all the numbers less than that. So I'm going to open my bracket to the left, and I'm going to put a square bracket there. And then graphing the other part, or W is greater than or equal to -1. Start at -1, and the numbers greater than that go this direction. So to write that in interval notation, we can look at our graph, and we have all these numbers that go off forever in the negative direction. So we're starting at -infinity, and we go up to 4, including 4, or, which means we're going to use this union. We're going to put all these numbers in, which is from -1 up to, and they go forever in the positive direction, so up to infinity. So that's how you would write that in interval notation to match this inequality notation. The graphing can really help with like how that interval notation looks. All right, so that is it for 9.2. Bring your questions to me on Monday. I'll see you then.